So once again, good morning, everyone. And let's quickly go through the previous session revision part. We discussed two-dimensional array, right? Looked at the how we can declare two-dimensional array, initialize it, what is the representation of two-dimensional array. There are a number of rows and columns and indexes 0 to 2, 0 to 3 that you can see on your screen, right? Then there are a few operations on two-dimensional array. We can go for transpose. When we say two-dimensional array, it's kind of a matrix that you have gone through in mathematics, right? So transpose of a matrix or determinant of a matrix, or you can sum difference, you can find difference, you can find product, and so on. So there are a number of operations. If you want, you can perform. So that was two-dimensional array operations. Now we are not going in depth of these operations, but we want to look at one kind of example here, some kind of thing. Just a minute. Yeah. So this kind of question may be asked. This is just a question to find out the address of particular element from the array. So let's have one example here. You have been given 4 cross 4 two-dimensional array here, okay? And the base address is also given. Base address, which means the 0th element address, okay? Now this is, if this is a two-dimensional array, then the 0th element will be A00, okay? So 0th element address is 5000 given to us. Then calculate the address of element A32. That's what we need to find out. A32. Okay. So does anyone have idea how we can do this thing? Or look, I'm not asking directly answer, but how can we do this? Can anyone contribute here? Just give it a thought. How we can calculate the address. If we have been given base address, then how we can calculate the address of particular element within the array. Anyone can speak, just unmute and give us the idea what you are thinking. Anyone? Well, let me give you a hint. A 4 cross 4, which means it will be something like this. This is your two-dimensional array, 4 cross 4, having indexes from 00 to 33, right? So 00, 01, 02, 03, then 10, 11, 12, 13, and so on. These will be the index values. And we need to find out address of A32, which is this element. Address of this element, and address of 00 is 5000 given to us. Any idea now? If no one is responding, so I have a question. Am I audible? First tell me, everyone can hear me. That's correct, right? Okay, so we have some answer directly. Fine. So Rajesh has given us has given us an answer 5028, and Keval is saying that by adding storage size of elements. That's correct, Keval. We need to add the storage size of number of elements that has been already passed, right? That's what we need to find out actually. Now, until and unless we know that this array is of what data type, we will not be able to directly calculate the actual size or the actual address, right? So in this question, it's okay, you have a base address 5000, but something is missing, which is the data type. It says if array A44 has base address this, then calculate the address of A32. But here we couldn't find whether this is integer array, this is float array, this is double array, or what. And in that case, we won't be able to say that one element A00 will be of 2 bytes, will be of 1 byte, 4 byte, 8 byte, what, right? So actually that is needed, and if it is not needed, then we won't be able to calculate actual answer. But we actually need to know the process, right? So look, whenever we say array, then remember array will always be contiguous in memory allocation. Now this is just a representation of two-dimensional array. This is just for us actually, rows and columns, okay? And 0 0 0 1 0 2 0 3, then 1 0 1 1 1 2 1 3, these are the index values. And in this manner we represent two-dimensional array. But actually this two-dimensional array in memory will be in a linear manner, okay? In your memory, all these elements will be in a single line, linear manner. So 0 0 0 1 0 2 0 3, then 1 0 will be after that, so second row. Once you complete your second row, then there will be third row, and after that there will be fourth row, and so on. And that will be contiguous in memory allocation, which means if we assume that this is integer array, if we assume this is integer array and the base address given to you is what, 5000, then this will be at 5000. And by assuming this is integer array, one element will occupy 2 bytes. So the next element will be at 5002, then 5004, 5006, and so on. And so this is how your continue memory will be allocated, and all the elements will be at this kind of memory addresses. So by knowing this structure, now we can calculate the address of any element. What we need to know is, let's say whatever element we need to find out, and if we know the base address, then we need to find out how many elements has already been passed before this element. So for this current row, you have 3 rows completed already. Now when we say we have completed 3 rows, so within that the total number of columns has already been passed. So number of rows multiplied by number of columns will be the number of elements passed. So 3 row pass થઈ ગઈ અને દરેક રો ની અંદર 4 એલિમેન્ટ છે. So 3 multiplied by 4, total 12 એલિમેન્ટ ઓલરેડી પાસ થઈ ગયા છે, કરેક્ટ? then within the current row તમે જે કોલમમાં છો -1 એટલી કોલમ પાસ થઈ છે, so plus those many elements more, so 12 plus 2 total 14 એલિમેન્ટ ઓલરેડી પાસ થઈ ગયા છે. જેટલા એલિમેન્ટ પાસ થયા છે એને મલ્ટીપ્લાય કરો એની એલિમેન્ટની સાઇઝથી, તો કેટલી મેમરી પાસ થઈ ગઈ એ તમને મળે. So that is how actually we calculate. So the equation will be something like this. If you say that you are going to calculate memory address of ijth element, ij, I is the row, j is the column, okay? Then I minus 1, okay, I minus 1 rows has already been passed, okay? Now for those rows, all the columns m cross n, if this is the size of your array, then n columns has already been passed for I minus 1 rows. So I minus 1 row, this is 3 here, 3 rows. Then n is the total size, which is 4. So 3 into 4, 12, plus whatever the current column you are in, minus 1. So if you are in a third column, then minus 1, which is 2. So 12 plus 2, 14. Total 14 elements has been passed. Now for those 14 elements, we will multiply it with the size of the element. Okay, size of the element. And that gives us the memory that has been passed. Now we need to add this memory calculation to the base address, because that's where we are started. We are not starting from 0, but the base address is given to us. So from this base address, we are going to add this calculated memory, and that gives us ijth location. Okay, so read this equation carefully, try to understand it, and if you do have any doubt here, then you can ask. Remember, this ij will be 1 base, whereas whatever indexes we calculate will be 0 base. Okay, that you should remember actually. So this mathematical equation is 1 base calculation, and the given indexes will be 0 base. If you want to make this equation 0 base, then there will not be any -1 here. I minus 1, j minus 1 नहीं થાય, તો તમે એને 0 બેઝમાં લઈ જાશો. So any question or doubt here? So in that case, if we assume that this is index, this array is integer data type, then Rajesh, your answer is correct one. should we continue, or you have any doubt now? Okay, so let's move on now. Now, this is very basic one, but we need to understand this part. And once you understand this thing, this equation you can create. You need not to mug up. If you understand this thoroughly, properly, then you can create this equation whenever you want. Okay. So that was two-dimensional array, memory representation, calculation of addresses, and so on. Now we want to look at the sparse matrix. Sparse. So sparse and dense. This is the word sparse here. So where there are more number of elements having value 0 in it, then we can say that's a sparse matrix. So a matrix where more number of elements are 0, less number of elements are having some value other than 0, then we can say it's a sparse matrix. Now, why are we considering this sparse matrix as a special topic or case here? So, for example, let's say you have 4 cross 4 matrix. So there will be 16 elements. Now assume that that is a sparse matrix. So from those 16 elements, let's say, you have only 6 elements with some non-zero values, and all other 10 elements are 0. Now just assume that if all those elements are 0, then do we need to store those zeros in a memory? Because 0 is not giving us any information, and to store a 0, we are wasting our memory actually. So if there is a special algorithm which gives us this benefit to not store those zeros, okay, so kind of algorithm and data structure that takes advantage of sparse structure of a matrix, then we can utilize our memory in a proper way. So we can spare our memory a little bit. By not storing those 0, we actually spare our memory. And that's why we are considering this as a special topic here. And we are going to look at those data structure and algorithms. It's nothing but a mapping. It is just a mapping. Okay. So let's have a look at examples, and then we understand how we can do that. So lower triangular matrix, if you consider, then you can say that half of the matrix, and this is a lower triangular, so below principal diagonal you will have values, and above principal diagonal you will have all zeros. That's what the lower triangular matrix is. Now you can say that, oh, if there are number of zeros here in the upper part of this matrix, then we need not to store it. If I'm going to store those elements as 0, then actually I'm occupying total memory of this two-dimensional array, where needful values are just in the below part, and this upper part is just a waste of memory. It is not needed actually, right? So to store this, if we can use 1D array and we store only those values which are needed, then we can spare this amount of memory. Okay, તો એટલી મેમરી આપણે બચાવી શકશું, આટલા એલિમેન્ટની મેમરી. અહીંયા 10 એલિમેન્ટ તમને એવા દેખાય છે. સો જો એ ઇન્ટીજર હોય તો એટલું જ તમે 20 બાઇટ બચાવી શકો. And that's what we want to do here. So if this is two dimension, તો જ આ problem આવે છે કે ભાઈ upper part ને store નથી કરવું. If it is one dimension, તો એક line માં બધી જ value નાખી દો, and you will have only those elements which is having values. જ્યાં value નથી, એ element ની જરૂર નથી. So that's what we think, but in that case, we are actually changing a structure. This is a matrix, okay, and matrix will be always two dimensions. Now if we store those values in one dimension, then we are lost in one dimension of the given data. So somehow we need to map this two-dimension matrix to one-dimension array, and by looking at that mapping, we come to know whenever we access values back, then we'll come to know that, okay, this value is from first row, this is from second row, this is from fourth row, and so on. So we need to define that mapping, okay? Mapping of two dimension to one dimension conversion. And that is this one. That's nothing but a row-wise mapping or column-wise mapping. So if this is a lower triangular matrix, then if this is a lower triangular matrix and we store these values in one dimension row-wise, so first comes 1, then we take second row 5 and 3, okay, then we take third row 2, 7 and 1, so we have 2, 7 and 1. Then we took the fourth row 3, 1, 4 and 2, so we will have 3, 4, 1, oh, 3, 1, 4 and 2, 3, 1, 4 and 2. So this is a fourth row here, and then the last row. So if we took those values row-wise, then it is simply called row-wise mapping. And if we took those values column-wise, like 1, 5, 2, 3, 9, so 1, 5, 2, 3, 9, then the second column, then third column, then fourth column, and so on, then it's a column-wise mapping. So what we need to know is which mapping we are following and what is the data. So if I say that this is your data and this is a row-wise mapping for lower triangular matrix, then you are pretty much sure that first row will have only one value. So this is the row 1. Then second row will have two values. So 5 and 3 is from second row. Third row will have three values. So 2, 7 and 1, this is your second row, and so on. So from one dimension, you can extract the other dimension also with this mapping, correct? So this is a row-wise mapping and a column-wise mapping for lower triangular matrix. Similarly, we can have upper triangular matrix also. So quickly give me row-wise and column-wise mapping for this given upper triangular matrix. Write both the mapping answers in chat box. Okay, so very quickly, some of you are giving answers. Row-wise will be the simple 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, then there is a change 1, 2, 7, 4, 5, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 7, 4, 5, 2. There. Yeah, that's row-wise answer is correct. And if you get one correct answer, then another one is very simple one. just go for the column wise. So 126, 371, 4824, 59752. That will be the column answer. Yeah, that's correct. Okay. Yeah, so you know that now. So what you are doing now, you are storing only those values which has non-zero content, right? And the elements which are zero, we are not storing those, and we spare that memory, right? So that's the sparse matrix. Now, if sparse matrix is a very small topic, and if question comes from this one, then it can be the short note of sparse matrix. What is sparse matrix? And how do we store sparse matrix in the memory? That kind of questions may be asked. So first you need to define what is a sparse matrix. The matrix which is having more number of elements, 0, right? That's a sparse matrix. Now what is the problem with sparse matrix? If we want to store the sparse matrix entirely, then actually we are going to store 0 values, and that is a waste of memory. So that's the problem. To solve that problem, we come up with different mappings, and using those mappings, we store this two-dimensional matrix in 1D array. And then you write down row-wise mapping, column-wise mapping, and then you give 1 or 2 example, upper triangular, lower triangular, and let's have one more mapping, and the third example, tri-diagonal matrix. Look, only one diagonal. If you say there is only principal diagonal, all others are 0, then you can simply store it diagonal wise. We are not going row wise, we are not going column wise, because there is no difference. So row wise, column wise, or diagonal wise, all those 3 will be equal. But now if we say there is a tri-diagonal matrix, so there is a principal diagonal and 2 more diagonal, one upside and one downside. So if you have 3 diagonals here and rest of the elements are 0, then you may go for row wise mapping, or you may go for column wise mapping, or you may go for diagonal wise mapping. This is another mapping, third mapping, and it is only for diagonal matrix. Okay, so the diagonal wise mapping is where you take principal diagonal first. Okay, then you take the diagonal which is upside, and then you take the diagonal which is downside. So 1 2 3 4 5, this is the principal diagonal. Then 6 7 8 9, this is the diagonal upside, and then you take 3 4 5 6, that is the diagonal downside. So the third mapping is diagonal wise mapping. It is used only with diagonal matrices. Okay, and you can give this example also for sparse matrix. Clear, everyone? Clear, everyone? Okay. So that completes the array part also, sparse matrix also. So at the end, we'll go for the applications of array. Now, this is very simple topic. Everyone knows what is the application of array. Whenever you have a list of data of the same data type, you can store those data in array. So it is widely used to implement mathematical vectors, matrices, other tables, whatever table you want to store data. But remember, data must be of same data type. Okay. So many databases also include 1D array to store record. One record will be stored in 1D array. And arrays are used to create few other data structures like heaps, hash tables, stacks, queues, and so on. So these are few applications of your array. Fine. And that completes our array part also. We have seen representation of array, 1D, 2D array, memory representation, and memory calculation. So that is storage structure of array. Then we have seen sparse matrix and representation, and we have seen applications of array. This was the content of your syllabus. And the next topic we want to go through is the stack. In stack, now starting from this topic, whatever we are going to look at is the new content for you all, because you haven't seen stack before and you don't know what is stack and how stack is useful. So looking at the syllabus content in stack, we start with the stack definition and concept, what stack is. Okay. Then we will see the operations on stack. So operations are nothing but the insert, delete operations, display operation. But in terms of stack, insert operation is called push operation. Delete operation is called pop operation. Okay. Then change is, as name suggests, if you want to change some value. Peep, we will see what it is, and display, which is not written here. So those are the operations on stack. Then police expressions and compilation and Tower of Hanoi, these are the applications of stack. Few applications of stack, okay, which is part of your syllabus that we will see. Otherwise, stack is used at many places. So that's what we are going to cover next. Now let me stop this presentation and start the next one for stack. Okay. By the time, if you have any query in array, you can ask me. Okay. So just give me the confirmation. You can see this screen now. Okay. So you have no doubts, and yes, you can have a look at my screen now. Fine. Now onwards, we'll be going through this way. I'll be explaining everything with this digital slat, and we will draw all those data structures. We'll understand by drawing live with some content already given on the slides. Okay. So we will start with stack definition. We will understand what stack is, and then we will see stack operations. That is initial target. So let's understand what is stack first. So stack is nothing but the ordered group of items. First thing you need to focus is it's a group of items, collection of items. Then second word important is ordered group. So there is an order, that it's not a random one. So who comes first, second, third, fourth, and so on. There is an order. So ordered group of items. And then comes one more word. It's a homogeneous items, which means all those items will be of same data type. Same data type, homogeneous items. Which means here you can see in the first image, you can say all are the stones. Okay, so it's homogeneous. All these are stones. So we can say it's homogeneous. Then there are multiple stones, or so group of stones, group of items. And then the ordered one. If you want to create this part, then you have started arranging these stones one after another. સૌથી પહેલા તમે નીચેનો સ્ટોન મૂક્યો હશે, એના પછી તમે એની ઉપરનો stone, and then one by one what you can do is you can create this stack, and this is a stack of stones. Okay, so that's one example. Here in the second image you can find the donuts, so the stack of donuts, or in the third image you can say it's a stack of books. So all are books actually. So homogeneous items, multiple items, so groups, and then the major word is the ordered group. So sequence does matter. Now why sequence does matter here? Because when we create a stack, then every time we are going to include new item on the top. ઉપરથી જ તમે એક વસ્તુ મૂકશો, એન્ડ જો તમારે કોઈ વેલ્યુ કોઈ વસ્તુ હટાવવી છે તો એ ઉપરથી જ હટાવશો, right? So you can perform insert or delete operation from the top only. તમે આમાં ઇમેજ 1 માં તમે નવો પથ્થર મૂકશો તો ઉપર જ મૂકશો, અને જો કોઈ પથ્થર કાઢવો છે તો ઉપરથી જ કાઢશો, બીકોઝ નીચેથી જો પથ્થર કાઢવા જશો then your entire stack will collapse. આખું જે તમે સ્ટ્રક્ચર બનાવ્યું છે એ પડી જશે. Which means if we say it's a stack, then anything that we want to do will be performed on the top only. So elements are added or removed from the top of the stack only. Which in other words, we can say most recently added items are at the top of the stack. Okay, so this is what the stack is. Now if we understand this structure properly, and we understand the behavior of this structure, then we can also say that whatever you add last will be the first to get out. Okay, સૌથી છેલ્લે તમે સૌથી top of the stack, સૌથી ઉપર જે મૂક્યું હશે એ જ તમે પહેલા કાઢી શકશો. So if you have a stack of books, so સૌથી છેલ્લી book ઉપર મૂકશો અને સૌથી પહેલી book એ ઉપરથી જ ઉપાડશો. So this book you will insert at last, and that will be the book you will take first, and that means it is a last in first out data structure. So LIFO data structure. Stack is a last in first out data structure, LIFO. Okay, so these are few examples and simple understanding what is a stack. Stack is nothing but an ordered group of homogeneous items where we can perform any of the operations on top only. એક જ સાઈડ ઓપન છે ત્યાંથી જ ઓપરેશન થશે, બાકી ત્રણ સાઈડ પેક. Okay, so that is your stack. Then Let us go for the array implementation of stack. Let's say we want to create that data structure. We want to create stack data structure. So આપણે એક એવો પ્રોગ્રામ બનાવવો છે કે જે સ્ટેકની જેમ કામ કરે. અને group of elements છે, which means we want to store multiple values. Homogeneous items, એનો મતલબ same data type છે. So we know that we can use array, because array is nothing but a collection of elements having same data type. So using array, if you want to create your stack, then what we need to do? So generally what we do is we draw our array like this, correct? But in terms of stack, I'm going to draw that array vertically. Okay, I'm going to draw that array vertically like this way. So there is no problem. I can draw one-dimensional array in any direction. So that's one thing. Second thing, in your stack, every operation will be performed on the top. So only that place is open. Other three directions are closed. So this is how we are going to represent our stack. So this is nothing but the array. It is only array, and we will draw that array like this one, and we will keep one side open, top of the array open. So we will perform insert operation or delete operation from the top. This is just a representation of stack. So we have a data array and we have a position top from which we can perform our operations. So we need data array, correct? And we also need one top to find out where am I going to store that value within the array. Because if this is my array, then I'm having 0, 1, 2, 3, 4 index values, right? So I need to maintain my top, whether top is pointing to 0, top is pointing to 1, top is pointing to 2, 3, 4, what? So top is going to manage how many elements are there within my array. And from that top, I come to know whether I'm having space to add new value or not. So we require these two things, okay? We require data array and we require one more variable top. Now combinedly these two, data array and a top, combinedly these two are going to create your stack. So when you combine these two, you create a single entity, you call it a stack. Then what we do here is we will create a structure for this. We will create a structure with two members, data array and top. Now if you just want to store integer data, then this will be integer data array, and top will always be integer because it is just the index value. Okay, so top is going to be integer always because that is just the index value. So this structure is going to behave like stack when we write insert, delete, display operations for this structure. And how to write those operations we will see later. But this is the basic structure that we need to create for array, for stack using array. So try to understand this part and digest this structure first. Have a minute or so, then we will move on. If you have any question in your mind, you can ask. So, ready everyone? So this is the representation of stack using array. And if we want to implement this data structure, this kind of data structure in a program, then in a program, we declare one structure which is having two members. One is the data array, and second one is the top pointer. Now, when you say data array, then you need to be sure that what will be the size of your data array. So capital N, or let's say you need to define max. So max is just the size of your array, okay? Because when we declare an array, we must be declaring the size of that array. That is prerequisite. So this is stack. Now we know that stack is last in, first out, LIFO data structure. And in or out, everything will be performed on top. So from top, we can insert, from top, we can delete. Then we need to maintain our top here. We need to maintain this top variable, which is actually the member of your structure. Fine. So need to maintain this top. When I say maintain, then from the initialization part up to every operation, insert or delete operation, we need to update this top. Alongside we store or delete a value, we also need to maintain this top variable. And we also need to initialize this top first, because when we declare this top as a member of structure variable, it may have a garbage value. So the first thing comes, basic operations are the initialization of stack, which means initialization of top, then insert a value in stack, which is called push operation, then delete element from the stack, which is called pop operation. Then there is one operation, if you just want to check what is the topmost element, you don't want to delete it, you just want to check it, then peep. Then simply you want to display entire stack, then it is display operation. Then you want to check that whether stack is empty or not, so is empty, and full or not, is full. These are few basic operations on a stack that anyone can perform. Now, as a developer, if we are going to create a stack and we are going to provide that stack to others, then we need to write all these operations also. So we need to create a program file which will have this data structure alongside all the operations that can be performed on that data structure, which means એક structure stack કરીને data array અને top variable એ લેવો પડશે અને સાથે સાથે આ બધા ફંક્શન બનાવવા પડશે C પ્રોગ્રામની અંદર કે જેથી યુઝર્સ એ ફંક્શન કોલ કરી શકે અને આ ડેટા સ્ટ્રક્ચર વાપરી શકે. That's what we need to do, right? So let's go for the first one, initialization of top. Now this is very simple process, but before that, let's say we want to understand how stack works. So initially, when I have my stack, I have a data array and I have all those elements with indexes 0, 1, 2, 3, 4, and so on. If I say my array is of size 5, then 0 to 4 will be the index values. And I will have one top variable. Now, initialization of a top says that you initialize your top with -1 actually, because top is pointing to an element, which means it is index variable. An index can never be negative. So when we say top is -1, we say your stack is empty. This is the initialization part. So initialization of top, we are going to initialize top with -1, and that indicates my stack is empty. But generally, whenever we do the insert operation, then what we do is we have our data array and we have a top variable, which is -1 right now. But if I want to store one value here, then what I'll do is I will update my top with ++, and then I'm going to store the value, let's say 2. That is what the process I'm going to do. If I want to add few more values, then again I'm going to update my top, and then I'll store my value. One more value, then update your top and store the value. So this is how you are going to perform insert operation. So every instantaneous time, wherever your top is pointing to, અત્યારે ક્યાં point કરે છે? 2 ઉપર. So at a current time, wherever your top is pointing to will be the topmost value. And if you want to delete it, you can delete from that place. 4 delete થશે તો top ને minus કરો. 3 delete થશે તો top ને minus કરો. 2 delete થશે તો top minus થઈને પાછો -1 ઉપર આવશે. So that's how actually insert and delete operation will be performed, but we will see those operations. But right now, what you need to have a look at is when you initialize your top with -1, it is the initialization of stack, or it is the initialization of your top variable. Data array will remain as it is. We will work with top only, and we'll store given values in data array. So to do that, what you need to write is you initialize your top with -1. But this top is what? It is actually the member of structure. So if your stack variable is S, or let me write it here. If you declare your stack variable like this way, struct stack, which is your structure, and then you declare your variable S. Then you do it by S dot top equals to -1. This is how you will do in a program. Now that's one thing. Now if you say that you have struct stack, you have a pointer variable S, okay, pointer variable of your data of your structure stack S, then you will use S points to top equals to -1. Remember, because whenever we have a structure and we have structure variable, if that is normal variable, then we use dot operator to access members. And if it is pointer variable, then we use arrow operator to access members. We'll stop here today. What we have covered today is we have seen sparse matrix, applications of array. Then we have started with stack. We have understood what stack is and few basic operations on stack. And we have looked at the first operation, initialization of stack. Alongside, we also look at the variable. If structure variable is a normal variable, then dot operator is used to access members. And if structure variable is a pointer variable, then arrow operator is used to access members. That's all for now, and we'll stop here. If you have any question, you can ask, or else you may leave this meeting and join the next one. Thank you. Yeah, Hanil, I'll upload first unit PPT today, okay? Any other query or question?